Today we're going to be using an awful lot of the knowledge you've gained so far with circles and equations of lines to look at triangles in circles. For all triangles, you can draw a circle that connects all of their vertices or corners. This is called a circumcircle. If you draw the perpendicular bisector of two of the lines, they will always intersect at the circle's centre, which we call the circumcentre of the triangle. Let's have a look at these questions. In this question we're asked to show that AB is the diameter of the circle. If AB is the diameter of the circle, then ABC must be a right angle triangle because an angle from a diameter is always a right angle. That's basic circle theorem. So we can use Pythagoras to test this. Let's draw a simple sketch first of all to see the sort of thing we're dealing with. You don't need to draw a sketch for this, but if you ever get stuck with what the question's asking, it can be really helpful sometimes just to draw a quick sketch. It doesn't need to be accurate. Next, we need to find the lengths of each line, but we do not need to square root since we need them to be squared later. So we're going to do AB squared and we're going to find that out by using Pythagoras. We don't need to square root, as I said, because we want our answer to be in terms of AB squared. So we're going to take away each of the coordinates and square them, and AB squared will be 100. We're going to find the length of BC squared. We're going to do the same between the coordinates of B and C, and we find the answer is 10. And finally, we're going to do the same with AC squared, and we find the answer is 90. Now, if AB is a diameter, then we should be able to square AC and BC, and it should equal AB squared, because that's basic Pythagoras. So let's put in our values. 90 plus 100 equals 90 plus 10 equals 100. So we know that it is a diameter because it must be a right angle triangle. In this question, we're asked to find the centre of the circle. Now this question has been quite kind because it has given us the equation of the perpendicular to DE. Now we know that the perpendiculars to two of the lines in the triangle will intersect at the centre of the circle. So we need to find two of them, but in this question we only need to find one. So we're given DE in the question, and so it's really up to you which one you pick. I'm going to pick EF, but it will work if you picked DF. So the perpendicular to EF, we need to first of all find the midpoint. So we're going to substitute in the x coordinates and the y coordinates and divide by 2, like add them together and divide by 2. So it gives us 5.5 and minus 1.5. Next we need to find the gradient. So to do that we do change in y, so take away the y values over change in x, so take away the x values, and we get minus a third. So the equation of the perpendicular bisector to that line will be the midpoints we can substitute into the equation form, but we need to find the gradient. Now the gradient of a perpendicular will be the changing the sign, so minus third will turn into a positive third, and find the reciprocal, so a third will turn into 3. So our m will be 3, and then our x coordinate is 5.5, which will be minus 5.5. And our y coordinate is minus 1.5, which will turn into a plus 1.5 because it's y minus the y coordinate. So we're going to expand the brackets next, so 3x minus 16.5, and then we're going to take away that 1.5 both sides. So we've got y equals 3x minus 18. Now we've got our two perpendicular bisector equations. We've got the one given to us in the question, and we've got the one we've just found out. Now remember, the centre is at the intersect of the two. They're both in the form y equals, so we can get them equal to each other. So 3x minus 18 equals half x minus 5.5. We're going to add 18 to both sides and take away half x from both sides, and then we're going to divide both sides by 2.5, giving us x equals 5. But we're asked for the coordinates of the centre of the circle. We've only got the x coordinates so far. So we're going to substitute that in to one of the equations. I'm going to pick the left-hand one just because the numbers are integers, so it might be easier. So y equals 3x minus 18. Substitute in that 5, so it's 3 times 5 minus 18. 15 take away 18 is minus 3. So the centre of the circle is at 5 minus 3. In this question we're asked to find the equation of the circle. Now we've already worked out the centre of the circle as 5 minus 3 and we've got the points on the circle. So the first thing we're going to do is find the radius, and we can do this between any of the points and the centre. I'm just going to pick D just because it's the first one. So we're going to do the square root of the distances squared. So 5 take away 8 squared, and then minus 3 take away 1 squared, because we use Pythagoras to find distances between 2 points. That will give us square root of 25, which will be 5. And the equation of the circle. Now, to do this, we're going to just have the formula for the equation of the circle, which will be x minus a squared plus y minus b squared equals r squared, with a and b being the coordinates of the centre and r being the radius. We know the radius, we know the coordinates of the centre, so we're just going to substitute them in. X is 5 at the centre, y is minus 3, so it becomes a plus 3, and the radius is 5, so 5 squared is 25. Let's finish with this. Kyle makes a triangle with points A at 0,2, B at 0,4 and C at 0,6. Explain why he cannot draw a circumcircle from these points. If you think you know, write it in the comments below. And you can come to onmaths.com or click the link in the description to access all of our free A-level papers and predictions, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.